All right, today we're going to conclude our chapter on radicals, and we're just going to graph them. Right? If you forgot what radical is, just this little square root symbol, or cube root, or fourth root, or whatever. And a function member is just a relationship, like an equation with two variables. So you wrote like f of x equals 2x plus 7. That's a function because it has both the x and then the f of x variable. All right, and we're going to graph two different types of functions today, the square root and the cube root function. And we're going to be doing radical ones, so it'll be the square root and the cube root. All right, so there's actually going to be two ways, right, for today. You can just enter stuff on, so our goal is to graph them, square root and cube root, so make sure we have that down. And then there'll be two ways you can do it. You can just enter them straight on your calculator. This video will cover how to do that. And then you can also, this one's actually going to be faster, right? If we've gotten good at the transformations at this point, it'll actually be faster if you can just transform them. Okay, and along the way, we'll also talk a little bit about domain and a little bit about range. And so maybe we want to jot down notes here. Domain is like the x values, like what values are possible for the x, and range would be the y values, the set of all possible y values. Okay, so next thing for notes for sure, graph these parent functions. So the square root function is going to be the parabola turned sideways. And sometimes they don't draw this bottom part of the parabola because there's this rule about functions that for each input, there can be only one output. So like if we had 4 as an example, we don't want that to have an output of both 2 and -2, right? That's not gonna fly. That's not gonna be a function. So sometimes they don't draw this bottom part of the function. And I think, yeah, in homework today, I'm not gonna draw the bottom part. So cubes look like this. The regular x cubed looks like that. Okay, and so the cube root kind of is somewhat like a sideways version of that. So if you want to draw that in, that's your parent, goes through 0, 0. Sorry, I didn't quite hit it there, but that's what the cube root of x will look like as a graph. All right, so you can just transform this like center point when you do the transformation stuff. Okay, so pause the video here. And so this is a square root function transformed, right? So this would be the parent of square root x, but it wouldn't matter if it's cube root. The same thing applies. So see if you remember what is a, h, and k. How does it change the function? Pause the video. All right, so we've done this a bunch before. So k makes it go up if we're positive back there, and down, it'll shift it down however many units. Okay, the h on the inside goes left or right, and it's opposite of what we think. So if we want to go left, we'd have like a radical x plus 2. That would make it go left. And if you want to make it go right, we would have something like x minus 3 or something. That would make it go right. A is the trickiest part. It does a stretch if it's more than one, compress, and these are all vertical. I should put this on here. I always forget that vertical. In the vertical sense, it'll stretch or compress. And it compress if A is between 0 and 1. So greater than 0 but less than 1. And then if it's negative, it'll reflect or flip. So that will happen if negative A value. All right. So let's do a couple basic ones here. And yeah, we can start to talk about, no, maybe I won't do domain and range quite yet. Let's just sketch these two. Let's not do the domain and range here quite yet. Okay, pause the video and see if you can sketch. All right, so we know our parent on this is square root x, which just looks like this, and I'm not going to draw the bottom half of it. But this one's just going to go down 2. So I'm going to be down here, and then I'm going to have just that part of it. So there's our graph of square root of x minus 2. And then when it's inside like this, it goes left or right. So that one's going to go left 1. And so it's going to be that same parent shape. Looks like that. And again, I'm not drawing the bottom half of the parabolas. Okay, let's get to a little bit more complex example. And I will actually do domain and range on this one too. So see if you can graph it, and then we'll do domain and range together in a second. Okay, so the graph is going to go up 1 because the 1 in the back. It's going to go right 3 because of this minus 3. And then it's going to be a compress, a vertical compress by 1/2. And then the negative part is going to make it reflect. Okay, so I'm going to go up 1, right 3. All right, and then instead of drawing it up this way, I'm going to draw it down the other way, and I'm going to draw it as a compression. So it's going to be flatter than it was before, right? And again, I'm not drawing the top part. So because of the negative, we're going to flip it up, and it's going to be upside down. So yeah, it just flips it upside down. So sometimes when I say reflect here, maybe just flip would be even easier to understand. All right, so domain and range. Domain is what is possible for x. Okay, and range is what is possible for y. And so I just do it graphically. So here's my x-axis, and it looks like here's all my points. The first point would be 3, 1, right? That's my vertex here. And so that means x starts at 3 and then goes to 4, 5, 6, 7. So we'd say x is greater than or equal to 3 for my domain. Similarly for y, we start at 1, right? But then we go down. So we go down to 0, and it even though it doesn't show it on here, it'd go down to -1, -2, -3, etc. So we say y is less than or equal to 1 because we start at 1 and then go down. All right. I'm going to go back and so just to make sure we got this, try the domain and range of this blue one from the previous question. So that blue one right here, what's its domain and range? Okay, so domain, so I'm going to label this point, this vertex point, so it'd be 0, -2, meaning x, we start at 0, right? We're starting at 0 on our x-axis, and then we're going 1, 2, 3, 4, 5. So we do x greater than or equal to 0. And for y, we start at -2, right, on our y-axis. And then we go up from there. We go -1, 0, blah, blah, blah. Even though it doesn't show it, it would go up and up forever and ever. So you'd say y greater than or equal to -2 for our range. All right, so I want to go back and show real quick too that you can use your calculator. So to put this in the calculator, I just put parentheses around the fraction and then make sure that just the -3 is underneath the check mark and not the +1. Right, so graphing that in here, I'd go to y equals and do -1/2, so -1 divided by 2. And then I'm going to do the square root key, which would be right here. And then x, I think it was +3, is that right? Oh, -3. Okay, and then I'm going to go hit the over arrow and then put the +1 here. And if you have an older calculator, you will need to do the parentheses. If you have like an 83, you will need parentheses on the inside here. Here I just hit the over arrow, and now the 1 is on the outside. Okay, so we're going to hit graph, and you kind of get what we'd expect. It's a little flatter than maybe I drew, but it's basically the picture that we've got there. All right, so let's try a cube root one, right? So I put the parent back here, and again, you can do it either way. Graph on the calculator or transformations will actually be faster. Pause the video, give it a shot. Okay, so transformation, we're going to go left 1, down 4. All right, and then it's going to be a stretch by 2. So it's going to pull it vertically. So this shape is going to get pulled vertically by 2. So I'm going to go left 1, down 4. And when you draw the stretch at 2, it's just kind of a guess. So I'm going to draw it a little more curvy than before. Sorry for the poor drawing there, but it's going to look something like that. And again, you're just guessing at how much it got stretched. All right. Let's do domain and range quick. So if you haven't already, pause the video and see if you can figure out domain and range. It'd be a good challenge for you. All right, so for x, we go all the way into the positives and all the way into the negatives. So the domain is all real numbers. Range is also going to be all real numbers because we go down forever and we go up forever. Even though it doesn't look like it's going up or down really, really slow, it does go down and up forever. Those are supposed to be arrows. Sorry for the poor drawing. So the range is also all real numbers. Y can be anything, X can be anything. There's no limit on it here. Again, on the calculator, if you want to see what this one looks like, when I enter it in Y equals, I got to do that times 2 first. So I'm going to do 2 times, and then I've got to get that third root. So I'm actually going to hit 3 next and go math x root, which is number 5. So I got the little third root, and then I get x plus 1. So here's what it would look like if you had an old calculator. You'd have to do x plus 1, close the parenthesis, okay, and then make sure that the minus 4 is on the outside. All right, and so we should get the graph that we expected. Again, that's drawn much nicer than the one I have, but we went left 1, down 4, and then stretched by 2 to get that shape. All right, so you can either use your calculator again, or transformations will be a little bit faster. All right, so let's do one final one here and do everything. You can do the graph either by your calculator or by transformations, and then do domain and range. And again, a transformation is going to be quite a bit faster. All right, so hopefully you had a chance to try it. And our graph, this just makes us go right 3. There's no up or down. Okay, and then I'm going to reflect and compress. So I'm going to draw this shape, but the reflect version of it, it just goes the other way like that, and then it's smushed down. So it's pretty hard for me to draw on this thing, but I'll try my best. So it's going to look like that, and it got flipped, right? It got flipped around. This part got flipped up here, and this part got flipped down there because of the negative. All right, domain and range. So looking at the graph again, it goes forever in both directions for x, so that's all real numbers. And even though it doesn't look like it, for y, it'll go up forever and down forever. So range is also all real numbers. All right, if you want to see it on the calculator one more time, you just go in here, make sure you do a fraction in parentheses, so -1 divided by 2, square root, no, cube root symbol, so I got to do times 3 math x root, and then I forget what's in there, x minus 3. And then I'm going to hit graph. We should kind of see what we expect. Again, it's a little bit flatter than I could draw, but that's roughly what it looks like. All right, that's it. Thank you for watching. This one is just graphing, right? We're graphing, and remember that there's 2 parent shapes. So go way back to the beginning. Remember, sometimes there's the square root ones, and sometimes there's cube root ones, and so the graphs look different depending on which type it is. All right, thank you for watching.